Hello and welcome to part 1 in TechRef of our electronics database section. This is on breadboarding. So what is a breadboard? This device right here is a breadboard. What it's used for is prototyping. That is when we have an idea about a circuit we may want to construct and we don't know if we have all the facts in place and we want to make a test run of it. Prototyping is part of our design wheel and our curricular competencies. You'll see that in the step just before testing. So we will hypothesize a circuit, we will breadboard it, and we can do that in this simulation right here. And then we can breadboard it in real life, test it before we commit to making a final circuit or doing any hardwiring or any soldering or any such finalized such things like that that would actually use up materials. The program we're using here to study the breadboard is called Fritzing. It's a free program. It's very simple to use, and although it doesn't simulate the circuit and show you when your LEDs light up or whether or not the circuit is working correctly, it gives you an opportunity to put together a circuit and send it back to me for checking. And I can have a look at it and tell you, oh yes, it's going to work, or no, maybe not, but here is why. Or yes, it's going to work, but here's some improvements you might want to try, or here's some different values you may want to put in with the components. So first off, let's look at the orientation of the breadboard, how it's wired. So we can see how this thing works just by clicking on any particular hole in the breadboard. So if we click on this one, we'll see that everything that's in yellow here is actually connected. So if you put a wire in this slot here, or in this one here, that whole row is illuminated. Same thing applies to this long horizontal row below it, and these two horizontal rows below it here. Now these are actually what we call your power and ground rails. Red generally signifies power, and blue or black ground, but you'll notice that there's ground here and also ground here, but these two are not connected to each other. So if you wanted to have ground on both sides or power on both sides, same thing applies on that level, you would have to make a physical connection between these two rails. So we can come over here to something called core parts and find wire. Scroll through until we find that. Here it is right here, breadboard view. Here's a wire. So what we'll do is we're going to connect these two ground rails together. So let's start at ground rail 1, draw that wire across, make sure you don't connect it to the power rail, that would be a problem, and ground rail 2. Now, if we click anywhere on the ground rail, we'll see that both of them are illuminated. Now, the second part of the breadboard are these tracks here. You see these tracks run horizontal. These ones run more vertical. Now, if we pick any random track on the board, let's pick this one, we'll see that it illuminates these 1, 2, 3, 4, 5 tracks. I started drawing a wire there, which I don't want, so I'm just going to get rid of that. But again, the 5 tracks below are not connected, so we have this gap here, this long physical divide in the board that basically divides this half of the board from this half of the board. So you have 2 full halves to use at any given time. Now, if we wanted to add a component, let's start with something very basic, a resistor. I'm going to grab a resistor, place it in the board, and you can see it's highlighting those 2 areas where it's going to connect. In the real live circuit board, you'll see a similar type of orientation. These pins on the resistors will span 3 or 4 or 5 slots. Now if we check what's connected, we'll see that these 5 are connected to the resistor, and these 5 are connected to the resistor. So if we want to make a connection to this side of the resistor or to this side of the resistor with anything, we can basically use any of these lit holes here. So let's just throw together a very quick circuit here. Let's use a red LED. Now, LEDs are polarized. Again, it doesn't really matter on this circuit, but to get in a habit, let's put it with the correct polarity. So anode on an LED is positive. On the other side, cathode is negative. So let's pick a couple of slots for that. These two. You see right away we've got this lit section. Oh, here's something interesting. My resistor wasn't quite in. So now you see that we have those illuminated green, just like the LED. Now we have power going to the resistor. So again, the cathode is negative, so we're going to hook that up to the ground. Let's grab the wire from the ground and hook it up to this one. Now when we check the circuit, we'll see that ground follows that path, goes through the wire and over to the cathode side of our LED. Now to finish completing the circuit, we will run, as you'll remember from lesson 1, we also need a resistor in line with these LEDs because there's generally too much voltage coming from your power supply. So we need to use this current limiting resistor to drop some of that out. So let's connect the positive side to one side of the resistor. And we'll take the other side of the resistor to the positive rail. Here. So now again we can see we've got positive all the way up to the resistor. The other side of the resistor is connected to the positive side or the anode of the LED, and the cathode of the LED is connected to the negative side. Now all we have left to do to complete this circuit is put some power to it. Let's move this up a little bit. Grab this gigantic battery pack. Now here's a neat little feature in fritzing. If you right click or two-finger click on your Mac, you can actually rotate these. So I'm going to rotate this up just to make it a little bit easier to see. It'll be 90 degrees counterclockwise against the clock. Now here we have the battery, and the black side, as we mentioned before, is the negative side, or the ground. So again, we're going to connect the positive side of the battery to the positive rail, and the negative side to the negative rail. Again, we have the whole thing connected, so it doesn't really matter which side we put it on. And last but not least, we don't have anything coming off of this power side here. Oh, yes we do. We have this wire right here. So now if we illuminate this power rail once again, we should see we have power from the battery to the positive side of the rail. We have ground from the battery here to the negative side of the rail. If we follow that circuit through, we'll see negative to the cathode, positive to one side of the resistor, and the other side of the resistor down to the positive voltage rail, giving us a complete circuit. From this point we can save this, share this online, send it to someone, and it's a good way to show how you're building a circuit. As we said, you could submit it for marks, or you could transfer it to someone else to continue working on, as long as they have the fritzing program installed on their computer.